Hello, everybody. Welcome to Crystalline's Virtual Learning Club. My name is Sarah Anene, and this is the mathematics class. Our lesson for today is indices. What are indices? The term indices is simply the plural of index. Now, an index is the floating number that appears as a superscript at the top right-hand side of a base number. It appears directly beside the base number. Okay, and indices show you how many times a number or a letter has been multiplied by itself. So the number 2 raised to power 3 2 raised to power 3. 2 here is the base number. And then this little 3 at the top right hand side beside the number 2 is what we call the index. And then this tells you that the number 2 has been multiplied by itself 3 good times. So this little number 3 here tells you how many times the base number has been multiplied by itself. Now, this is something for you to note. Many students make this mistake in examination. Like I said, the index only applies to the number beside it, directly beside it. And so when you see 3a raised to power 2 in this context, the power of 2 only applies to the letter A because that is what is directly beside it, okay? It does not apply to the number 3. So 3a raised to power 2 is equal to 3 times A times A. However, if you see this same thing in a bracket, it tells you that the power of 2 applies to both numbers. So 3a raised to power 2 in a bracket like this means 3a times 3a. I hope we get that right. So what are the laws of indices? The first law of indices says that any number raised to the power of 0 is equal to 1. Of course, with the exception of a base 0. So if you have 0 raised to power 0, it does not give you 1, okay? So any number raised to the power of 0 equal to 1. For example, you could have 3 raised to power 0, it's 1. Whether it is 78 raised to power 0 is 1. Or whether it is a raised to power 0, the answer remains 1, okay? The answer does not change. And so the second law of indices says when multiplying two identical values presented in index form, maintain the base and add the powers together. This can be represented thus. So a raised to power m times a raised to power n is equal to a raised to power m plus n. Now this can apply because you have identical numbers here, identical values, a and a. If you had a and b, this rule will not apply. So the only reason why this rule applies is because these numbers are identical, okay? So you have an example could be 3 raised to power 4 times 3 raised to power 2. Like I said, because they are identical numbers and you are multiplying, what do? You simply add the powers together. So this will give you 3 raised to power 4 plus 2, which is 3 raised to power 6. The third law says when dividing two identical values presented in index form, maintain the base and subtract the powers. So when you are multiplying, remember you add the powers, or when you are dividing, you simply subtract the powers. So this says a raised to power m divided by a raised to power n is equal to a raised to power m minus n. Again, the only reason why this rule applies is because these two numbers are identical. So this says, the example here says 3 raised to power 4 divided by 3 raised to power 2 will give you 3 raised to power 4 minus 2, which is 3 raised to power 2. The fourth law of indices says when raising a value presented in index form to another index, multiply the powers together. When raising a value presented in index form to another index, multiply the powers together. Now, this is a very cool way to represent this. It says x raised to power m all together raised to power n. And so what you're supposed to do is just to say x raised to power m times n, okay? This is a very good example. So if you have 3 raised to power 2 all raised to power of 3, so what you're supposed to do is simply to add these powers together to give you 3 raised to power 2 times 3, which is 3 raised to power 6. The fifth law says when you have a negative indices, express it as 1 divided by the base raised to the power of the index digit. Now, this you would understand this better with an example. Take for instance, you have x raised to power minus m. Whenever you see minus here, all you have to do, like whenever you see a base raised to a negative indices, all you have to do is to say 1 divided by the base raised to the specific index. Okay, so this says x raised to power minus m would give you 1 divided by or 1 over x raised to power m. Okay, so the example here says 3 raised to power minus 2. Again, because of it is negative, what do you say? 1 divided by 3 raised to power the specific index, which is 2. So of course, 3 raised to power 2 will give you 9. So your answer will be 1 divided by 9, or 1 over 9. And then the last law says, when you have fractional indices, make the denominator of the fraction the root of the base number raised to the power of the numerator. Now, this is a little bit more complicated, but you will understand it better with an example. So this says a raised to power m all over n. This is a fraction, right? So what do you have to do? M, of course, is the numerator, the number on top of the fraction, and then n is the denominator. So you're going to say n, the nth root of a, all raised to power the numerator, which is m. So in this case, it says 8 raised to power 2 over 3. The denominator is what? Is 3. So you're going to be looking for the third root, right? We call them the cube root. So you're going to say the cube root of 8 raised to power 2. Now you can do this equation anyhow you want it. It's still going to give you the same answer. You could choose to first find the cube root, and then you check the square, or you could choose to square it first, then find the cube root. You're going to get the same answer. So this says the cube root of 8 is what? The cube root of 8 is 2, because 2 times 2 times 2 will give you 8, right? So the cube root of 8 is 2, and then you're going to find the raised to power 2. So 2 raised to power 2 is 4. Or you could decide to first raise it to the power of 2. That means by saying 8 raised to power 2 will give you 64. Then you find the cube root of 64, which will give you 4. And this is just a simple equation to put to practice what we have learned today. So this says simplify minus 243 raised to power minus 2 over 5. Now, using the rule, right? The rule that applies to when you have a negative index, what do? Remember, you say 1 over the number. So this number is minus 243. So you're going to say 1 over minus 243. Do not forget to add the power. The power here is what? 2 over 5. So you have 1 over minus 243 raised to the power of 2 over 5, right? So now we are going to apply the other rule, because this is now what? This is now an index, a fractional index, right? So what you're going to do, remember, you're going to use the denominator as the root, and then you're going to use the numerator as the power. And so this is going to be 1 over the fifth root of 2 minus 243 raised to the power of 2. And so the fifth root of minus 243 is what? Minus 3. Because when you have minus 3 times minus 3 times minus 3 into 5 places, you're going to get minus 243. So your answer becomes 1 over minus 3 raised to power 2. Of course, minus 3 times minus 3 is going to give you 9, because minus times minus is plus. So your answer becomes 1 over 9. I hope we I hope we understand this. I'm sure we're going to do better with more examples. So thank you very much, and see you in the next class.